Okay, so let's look at number 8. Number 8, we're not going to distribute out, okay, like we did on number 7. We're trying to go backwards and actually factor. So we already have the polynomial distributed out as far as simplified out with no parentheses. We're trying to go backwards and create these parentheses, okay? So let's go ahead and start. The first thing that we want to do is that we want to solve these for their zeros. That means whatever this graph looks like, okay, in this case, again for extra practice, positive 6 says it'll go up, 2 says it'll have 2 possible x-intercepts, and if I subtract 1 from that power, I have 1 change of direction. So it could look something like this per se, okay? Specifically a little bit more just for extra practice. If x's were 0, then I would have a y-intercept of 4. So at 0, 4, this is where it's actually going to cross the graph. So we could say that it could also look something like this. Okay, my point is that I'm trying to find out what are these x values of where it actually crosses the x-axis. And you can do this with a calculator, or you can do this by hand. Okay, so let's try to do this by hand first. Alright, so I have 3 terms. The very first thing that I would try to do after setting it equal to 0 is that I would try to see, is there a GCF amongst these terms? Is there a greatest common factor that I could divide out from all of these 3 that they share in common? And in this case, the answer is no. So then I'm going to move on to setting it still equal to 0, but I'm going to create 2 binomials that would be the factors of this 6x squared minus 11x plus 4. So here's the step. Here are the steps. These first 2 right here and here will multiply to give me a 6x squared. So I could try 3x and 2x, or one could be 6x and the other one could be 1x. Okay, so I tend to go for the ones that are in between. Again, I know the factors of 6 could be 1 and 6 or 2 and 3. I typically try to go for the ones that are closer together. Okay, now the next number that I'm going to concentrate on is this positive 4, because I know these last 2 terms on these 2 binomials will multiply to get a positive 4. Okay, so let's think about factors of 4. I could do 1 and 4 or 2 and 2. Okay, so the 3x and the 2x, chances are those will always be the ones that are closer as far as that center part, that center marking that I was telling you about. And I have a choice to either do 1 and 4 or 2 and 2. So yes, it is a little trial and error, but it is a way that you can solve these pretty efficient if you get good at this. So let's try the 1 and the 4. Okay, I have 2, because they will multiply. I have 12. And I know that if I add those, I could get 14, or if I subtract it, I could get 10. My goal is to get this negative 11 right here. So none of these are negative 11, so that 1, 4 didn't work out that well. So quickly just undoing this, I'm going to try to rearrange it before going to that 2 and 2. So let's put 4 here this time and leave 1 here. We have 8 and we have 3. So 8 and 3 will add to get 11 or subtract to get 5. Now just like we said before, we want this negative 11, and there it is. The 11 pops up. Now we just have to worry about signs here at the end. Okay? So just like we said they will multiply to get this positive 4 and add to get this negative 11, that means these both have to be negative, because a negative 4 times a negative 1 would give us the positive 4, and then this negative 8 times this negative 3, or adding with this negative 3, will give me this negative 11. So these are our factors, if you will. So it says factor completely to find all the zeros. So we did the first step of factoring. Now we just have to find the zeros. And that means just find the x's that would make this all equal 0. Okay, so that's 3x minus 4 set equal to 0, 2x minus 1 set equal to 0, and we're just going to solve for the x's for each one. Adding the 4, we get 3x is equal to 4, therefore x is equal to 4/3. Here, adding the 1, we get 2x is equal to 1, and x is equal to 1/2. So we have x is equal to 4/3 and x is equal to 1/2. Now, let's think about this. That means if I were to put 4/3 here and here, we know that for this binomial it would be 0 times something not 0, but anything times 0 will check out and will become 0 in the end. So that's how we know 4/3 is one of the zeros of the function, one of the answers, one of the solutions, x-intercepts, however you want to refer to it as. And then checking our answers by plugging this back in here and here, this would be 0, and this would be like 3/2 minus 4. It'll be something that's not 0. But anything times 0 is going to equal 0, so that we know x is equal to 1/2. Is also a solution. So these are zeros, solutions, they're all synonymous, mean the same thing, or x-intercepts. And again, these over here, 3x minus 4 and 2x minus 1, are factors. Otherwise, the roots of this polynomial. Okay, so 2 parts to them to get the answer. Now, if I wanted to do it with a graphing calculator, because some of you might not be strong with your number sense and that trial and error approach, you can always graph these as well. Okay, so 6x squared minus 11, let me show you how that would look like. Alright, so we'll come over here, we'll say, let me go ahead and grab a new document, because we were using this earlier. And then I will control add a page. I'm going to add a graphing page. And then I'm just going to go ahead and put the binomial, or the polynomial, 6x squared minus 11, 6x squared minus 11x. And then it's going to be added with 4. Okay? And what I'm looking for are, in fact, these x-intercepts that we see right here and right here. So if we find those x-intercepts of when it equals 0, we should get these values here. Okay? So let's go ahead and do that. So I'll press, let me get this cleared out first. I'll press menu. I could do trace, so number 5, and graph trace. And slowly just start scrolling until you get to an x-intercept, and it says the x-intercept is 0.5. You can see it way down here. It says 0.50. Whoops. Let me escape from that. And then I can do it again. Menu, trace, graph trace. And I can go to the other one, and it says 1.333. Okay? So we had 1/2. Let me show that over here. And we also had this 1 and 1/3. Okay? Converting mixed fractions from 5th grade to improper fractions, we know 3 times 1 plus 1 is 4/3, and we have 1/2. So that's how we get the 4/3 here. That's how we get the 1/2. Now some of you are thinking, if I use that calculator, how am I going to get it to look like the way that we got with non-calculator? Okay, and I'm talking about this right here, this 3x minus 4 and this 2x plus 1. Well, let's set x is equal to, this 1/2 would look like this, okay, because you're always doing the opposite sign. And then this 4/3, we'd have x minus 4/3. And all you have to do is just multiply those two to rearrange it to get 2x minus 1. And then multiply these two to get 3x minus 4. And that's how you get to what we did by hand. So either way will work. I prefer the algebra as far as showing the work, but if you want to utilize the calculator just like we said you could, you're more than welcome to. Alright, so now let's keep going with the other examples, okay? So B, we have 2 terms. And again, just like on all of them, when we are factoring, our first go-to is to try to see if we can GCF something. So a greatest common factor. Well, we notice an x in both of them, so I can factor out even a negative x if I wanted to. So what would be left here after I factored out would be an x squared. And because I divided by a negative, okay, I divided by a negative x, I'd get a negative 25. Okay, so, and again, you can check this if you want to redistribute to see if you'd get your original polynomial, which in this case you would get a negative times a negative to get that positive 25x. Now we set it equal to 0. Now we have two terms here. We have negative x, there's multiplication right there, is equal to 0. And then we have x squared minus 25 is equal to 0. So if I divide by negative 1 over here, I still get 0. I know that's an answer. And I can move this 25 over. And then some of you will take the square root. And I hope if you do it this way, you remember a plus and minus there. So it'd be a positive and a negative 5. So there's two answers there. You can write them like this or like that. Okay? If you don't remember this plus or minus when you square root something, some of you will also identify that there's a difference of squares there. So the difference of squares could further be factored out to x plus 5 and x minus 5. Okay? Because it's the square root of x to get each of these square x's, and it's the square root of 25 to get each of these 5's. The fact that this is negative says that your signs in your difference of squares, one will be opposite of the other. Okay? And yes, if you were to solve this out, this negative 5 would go here, and this positive 5 would go there. So you have x is equal to 0, and x is equal to plus or minus 5. Okay. Now let's go on to the next one. I have another possibility of a GCF. If I can divide everything by x or divide by 9. In this case, I actually don't have these divisible by each other, so there's no GCF. So I'm going to go straight to seeing if I could have two that factor out that would multiply to get 9x squared. So let's look at our first terms. These first terms, this was like letter A, the way we did the work on letter A, will multiply to get 9x squared. So again, I'm going to go for those center ones. Instead of 9x and 1x, I'm going to use 3 and 3. And then I'm going to try to come over here, and I'm going to try to take the square root of this one. Okay? So this is a difference, which is that subtraction sign, of squares. That means I can square root 9, I can square root x squared, and I can even square root 49 cleanly. So 49 becomes 7 and 7. And just like we talked about on that difference of squares part in part B, this negative means that one is a positive and one is a negative. Okay, so let me just show you the work redistribution-wise. We get 9x squared, we get a negative 21x, we get a positive 21x, which goes to 0, and then a negative 49. So that's why we don't have this x term written there, because it went to 0. Okay, and everything still works out. I just wanted you to see that so you can trust that difference of squares. Now that means if this multiple is equal to 0, or this multiple, or factor if you will, is equal to 0, those are where my solutions will lie. Okay, so subtracting the 7, and some of you may skip a step or two here, and dividing by 3, we get negative 7/3. So negative, 7/3. And then if I add the 7, and then divide by 3, we get positive 7/3. So a negative 7/3 and a positive 7/3 would be the zeros, otherwise x-intercepts, and these would be the factors. Remember, on the test, we are looking for both. Alright, let's go to our last one, J. Now, again, just like all of them, I'm going to look for the GCF first. There's nothing that they all have in common. And when I see 4 terms, I try to group them into 2 pairs and then try GCF again. This is only if there are 4 terms, okay? If there's 3 or 2, you can't necessarily do this trick, but you can when there's 4 terms. Alright, so the GCF on the first one is x squared. That means what would be left over if I divided by this x squared would be x plus 1. Okay? The next term that I'm dividing out would be a negative 25. Remember, you want the greatest common factor. And what would be left over would be this x plus 1. Now, if you're doing this correctly, of course we set it equal to 0. If you did this correctly and it is factorable, these two will be the same. Okay, so you're looking for that pair that you're going to write down one time as one of your factors. What's outside of parentheses is your other answer. So what's inside parentheses is 1. What's outside parentheses is the other. X squared minus 25 in parentheses. Hopefully by now you notice this is a difference of squares, which is x plus 5, x minus 5, and then you just bring down your last factor of x plus 1, and this is your factored form. So that's the first part. Now you just got to set each of these equal to 0. Okay? Or just remember that this is the opposite. X is equal to negative 5 for the first one, positive 5 for the second one, and negative 1 for the last one. So your zeros would be there, the factor form would be there, and that is the completion of all the pieces of number 8.